Woohoo! Welcome back. Today we're going to be talking about exponential and logarithmic equations with our friend Squirrel. Yay! We're going to be taking everything we know about exponential functions and logarithmic functions and using that to talk about equations involving exponential expressions or logarithmic expressions. Woohoo! In general, when we're asked to solve, if we are asked here to solve, there's almost always an expectation that we should solve for exact values, although we will also be practicing by approximating the answers as well to 2 decimal places. But in general, if someone in math asks you to solve an equation, they want the exact value. Okay, let's get started. Woohoo! So, first question, 3 to what exponent gives me 14? Now, why is this an interesting problem? Well, this is an interesting problem because 3 squared is 9, and 3 cubed is, you got it, 27. So to get to 14, we must be picking something that's between 2 and 3 for an exponent, because 14 sits between 9 and 27. We'd like to actually calculate an exact value. And so I'm going to go ahead and say, okay, we've got 3 to the x equals 14. So we've got some options. And here it's important to note that everybody has different perspectives on the correct way to go about this. One way to solve this is to go ahead and use, take this exponential form and rewrite it in logarithmic form. And that would be great, except that my base is 3. And if I do have to use a calculator to solve it, I don't have a log base 3. So I'm going to choose to either use common log or natural log because, again, I've got common log right there and natural log right there. And so they're going to help me calculate a value, an approximate value, but still a value. And so I'm going to go ahead and use log, this time common log. And I'm going to use the fact that logarithm, if you remember the graph, it's that beautiful increasing curve like this. It's 1 to 1. And so if I have 2 values which are equal, like 3 to the x equals 14, these two things are equal, I can take the logarithm of both, pardon me, squirrel, and I could say log of 3 to the x has to equal log of 14. So I can apply the logarithm to both sides. Now, how does this help me? Well, it helps me because then this exponent comes down in front. So I get x times the log of 3 equals the log of 14. Or x equals log of 14 divided by log of 3. See how I did that? I divide both sides by log of 3. Now, this is the correct answer. This is the exact answer. But if someone's asking you for an approximation, log of 14, close the parenthesis, divided by log of 3 gives me the answer 2.40217, some other stuff, which means that I'm at approximately 2.4 is my answer. Now, remember over here, we said it had to be between 2 and 3. It is. It's 2.4. It's almost halfway, but a little closer because 14 is a little closer to 9 than it is to 27. In fact, it's a lot closer to 9 than to 27. Okay, woohoo, we got one down. Yay, let's do another one. Okay, next one. Next one is kind of interesting. Let me draw a line so I don't get too confused, because boy, do I get confused easily, right, squirrel? I know. It's like when you bury all of your nuts and seeds and then winter comes and you're like, oh my gosh, where did I put that? So this one, when you take a look at it, is initially going to look a lot harder because it's got that E in it. And if you're not used to seeing E as a number, it can feel intimidating. But the good news is in terms of a calculator, oh, let me clear that. In terms of a calculator, we've got natural log and e to the x right there. So this is actually going to be easier. I don't have to choose a logarithm. I know that I want to use natural log. Now, you can either convert this to logarithmic form, or you can apply the natural log to both sides. Since it's something we've done before, I'm going to go ahead and convert to natural log, or to the logarithmic form. So I'm going to use natural log, log natural, and I'm going to say convert to log form. Remember what we do is we do log base e, so that's our base, then we go across the way of 14 equals 2x plus 1. So now where does that put us? Well, log base e is natural log of 14 is equal to 2x plus 1. Now, how do I solve for x? Well, I just have to isolate x. Personally, I feel comfortable using this form, but what a lot of people might want to do is rewrite it as 2x plus 1 equals natural log of 14. Then I could subtract 1. I get 2x equals natural log of 14 minus 1. And then I divide both sides by 2. And I get x equals natural log of 14 minus 1 all over 2. Oh, I forgot the last parenthesis. And that's our exact value. What we could do is go ahead and take the natural log of 14 and then subtract 1 and then divide by 2. And I get, if we're rounding to 2 decimal places, 0.82. So just under 1. So does this make sense? Well, this is going to be hard to approximate, but e is just under 3. So if I have something between 2 and 3, what exponent would it take to get it up to 14? Well, 2 to the 4th is 16, so maybe this should be about 4. And 3 squared is 9, so this value should be between 2 and 4. If my x value is slightly less than 1, then this is going to be slightly less than 3. So it's between 2 and 4. So sure, that does make sense. Woohoo! And again, I feel like I should be pointing out that this is the approximation right here, but the exact value is what we're actually looking for usually. So here's the exact value. And then here's the approximation. Okay, number 3. Woohoo. We are just moving right along. Oop, don't look at that. Don't worry about that one. Don't worry. That's a in 5 minutes circus. It's not a right now circus. Right now circus is right here. So I've got 15 e to the x equals 3. The key to working with this one is to recognize that this 15 can't be in front of the e raised to the x power and still allow us to use natural log to fix anything. We got to move this 15. So since it's 15 times e to the x, I'm going to divide both sides by 15 and get e to the x equals 3/15 or 1/5. Does that look right? Okay, now I've got e to the x equals 1/5. I can, since we're already in e, I'm going to convert to log form and get log base e of 1/5 equals x, or natural log of 1/5 equals x. So x equals the natural log of 1/5, which again, if we want to come up with an approximation, natural log of 1 divided by 5, or you could put in 0.2 equals, and then here it's interesting to note, it's a negative number, right? You remember the shape of log and natural log, they do curve upward, but for x values, not for x values, I shouldn't say it, that's confusing. For arguments, for numbers like 1/5 that are between 0 and 1, the answer will be negative. So I've got approximately negative 1.61. I'm going to go with 2 decimal places for that. Okay, so far so good. And again, this is the exact, and this is the approximation. And it's important to know the difference between the two. Okay, let's move on to the last one on this page. Woohoo, this is very exciting. Hopefully this is making lots of sense. If not, pause the video, ask me questions, find tutors, ask them questions. Go out, on the street, ask random passers-by questions, make new friends, do logarithms. It'll save the world. I believe that in my heart. Okay, so I've got this kind of scary, maybe intimidating, maybe you're looking at this going, oh, no big deal, problem. And then I've got this hint that says exponential functions are 1-to-1. Okay, so what does that mean? That means each x corresponds with exactly 1 y, and each y corresponds with exactly 1 x. What does that mean? Well, it means that if I get 5 to the 3x is equal to what I get when I take 5 raised to the x minus 6, then I know that the powers must be equal. So if the bases are the same and the whole expressions are the same, the exponents have to match up. They just have to. In which case, I subtract x from both sides. I get 2x equals negative 6, or I get x equals negative 3. And this one, the exact and the approximation are the same. Woohoo! And let's double check that. If you plug in x, over here you get 5 to the negative 9th. If you plug in x equals negative 3 over here, you get 5 to the 9th. Woohoo! Nicely done. Okay, we've got one more problem, I think. Yes, are you guys ready? Deep breaths, think of happy thoughts. Problem number 5. This is exponential with the exponential, right? So we've got e to the 2x minus e to the x minus 6 equals 0. And I'm hoping that something about this is making you think of quadratic form. Because in fact, you see that the 3 terms and the e to the x, and this one's e to the 2x. This is e to the x squared minus e to the x minus 6 equals 0. That's quadratic form, right? So that's this one. Something squared minus something minus 6 equals 0. We can either try to factor this, or we can use the quadratic formula. I'm going to use the quadratic formula. And just because you might be feeling a little rusty, the number in front of the squared is a, which is 1. B is right there. And C is right there. Okay, so what are my expressions going to be? What are my expressions going to be? I don't know what that. What is this formula going to look like? Well, I've got e to the x is what's in my box. And here I've got b squared. My goodness. Let me write it down because clearly 4ac 2a. There we go. I need a little help with that. There we go. This is what happens when my brain lets me just start talking and then comes back and it's like, what are you doing? What are you even saying? So I take the opposite of b, which is the opposite of -1, plus or minus -1 squared minus 4 times 1 times -6 all over 2 times 1. So that's 1 plus or minus radical 1 plus 24 all over 2, which is 1 plus or minus radical 25 all over 2. Sorry, that got a little smaller. Oops, sorry, squirrel. So that's equal to 1 plus or minus 5 all over 2, which is 1 plus 5 over 2, or 1 minus 5 over 2. So that's 6 over 2, or -4 over 2, which is 3, or -2. Now, do we put a box around these? No, because we're not finished yet. And I'm going to use some of this space to come up over here to finish the problem. Now, what is equal to these? So we go back up here, e to the x. We've got e to the x equals 3, or e to the x equals -2. And something interesting happens here. The interesting thing is you can tell I've got my red pen. Something really interesting is going to happen. E raised to the power x, no matter what x is, cannot equal -2. This is not possible. E to the x has to stay greater than 0. Remember, when you take a picture of e to the x, it's that shape that goes up like this, and it's got an asymptote at the x-axis, but it never touches, so it can't be negative. It never goes through. So our final answer is e to the x equals 3, or natural log of 3 equals x. Take a moment, see if you can get from e to the x equals 3. I did log base e of 3 equals x. X equals natural log of 3, which is the exact answer, or, very exciting, natural log of 3 is about it's about 1.10 if I go to 2 decimal places. Oops, sorry, didn't mean to blind you with the ring light there. So we go from here to log form, and then we've basically solved it. Woohoo! Yay! Awesome work. So that's it for this first part. This was exponential equations. Now in the next video, we're going to go through and do logarithmic equations. Yay! I know you guys are all like, yes, bring on the logs. We love logarithms. I know. But I'm going to still recommend you take a break, get out, get a little exercise, maybe a little dance party, and go out and catch some sun if there is any, or enjoy the rain or the moon or whatever is outside. Enjoy it, or maybe enjoy family or pets or friends inside, and know that you're amazing and incredible, and I'm very proud of you, and I hope that you math on. Woohoo!